Hi all, my name is Nitin, and today we are going to discuss about Azure Kubernetes Service followed by a demo. So let's start. Azure Kubernetes Service is a managed Kubernetes service in Azure. So it is completely managed service in Azure. Azure will manage the Kubernetes cluster for you, and it will just offload the complexity and operational overhead of managing the cluster from the user. Health monitoring through Azure Monitor and Log Analytics. So Azure will do the health monitoring through Azure Monitor and Log Analytics for control plane component as well as worker nodes. AKS is free, pay for just agent nodes. So you don't need to pay for AKS. You will just pay for agent node which you are running as part of your cluster. Azure AD integration, so you can easily integrate AKS with Active Directory. With that, you can give existing Active Directory user and group access to Kubernetes cluster, and later you can control access to Kubernetes cluster from the group of users or group of groups through RBAC in AKS as well as in Azure level. Minimum downtime during cluster upgrade. So when you are to do upgrade activity on control plane component, AKS or the agent node, it is very easy. So it will take care of coding and training of the node on which you are to do the upgrade, and it will shift the workload to the new agent node. Once the workload is shifted to the new node, the old node will be deleted. So it is basically simple, and it will be done with minimum downtime, basically equivalent to seamless for user. Support for GPU enabled node. So it supports for GPU enabled workload. So suppose you are to provision a Kubernetes cluster or the container which is CPU intensive and required for machine learning. So you can opt for GPU enabled worker nodes. Azure Disk for single pod access and Azure File for concurrent pod access. So when you are running a stateless application, so you can always use Azure Disk. And if you are to use a shared concurrent storage, then you can always use Azure File Storage for that purpose. Virtual network IP address assigned to each pod when you are launching the pod as part of your workload, then it will be assigned with an IP address from that VNet, and VNet can further be can be further paired with other VNet, or it can be linked to the on-prem through site-to-site or P2S, right? So that way you are giving access, or you can say scaling access to the pod to multiple networks within cloud and from the on-prem to ingress with HTTP application routing using add-on. So with that, what we are saying is, so when you are exposing any service to access it from outward or the public, then it can be configured to launch a DNS name every time, and you can just go ahead and use your application with that DNS name instead of using public IP address. Integration with ACR. So you can easily integrate AKS with Azure Container Registry, where you can keep your neat and clean images, and you can scan those images as per your need. AKS is CNCF certified and compliant with SOC, ISO, PCI DSS, and HIPAA. Let's see what are the launching methods with which we can launch AKS cluster. So there are a couple of methods with which it can be done. So Azure portal, you can directly go into the portal and launch the AKS cluster. And Azure CLI, so you can leverage Cloud Shell, or you can install Azure CLI on any Linux machine or Windows machine, PowerShell, and launch the AKS cluster. Resource manager template, so you can use a template also to launch the AKS cluster. Terraform, so suppose you are having an automation tool like Ansible or Terraform, so you can leverage that to provision your AKS cluster. Okay, so let's start with a demo. So in this demo, what I'll do, I will launch a AKS cluster using CLI, Azure CLI from Cloud Shell. So you don't need to install CLI. So when you will launch a Cloud Shell, then Azure CLI will be automatically installed over there. And I will deploy a voting sample application on that cluster. The code for that is already provided in Azure and GitHub. Walk through the services launched as part of cluster. I will walk you through what all services are configured and launched under the hood when you launch a AKS cluster. Delete the cluster. So finally, I will just go ahead and delete the cluster and wrap up for the demo. Okay. So let's start. Let's launch a Cloud Shell from this portal, and here is the button to launch the Cloud Shell, and it will take a minute to launch the Cloud Shell. So meanwhile, let's jump into the other tab of it and see if how many services are currently there. So I have recovery service vault and one storage account. That storage account is basically the part of Cloud Shell which I'm gonna launch here, and this is the recovery service vault which I use for some other purpose. So these are the two resources which I have currently in this, right? Let's hit refresh and make sure that there is nothing else there, right? So here I'm on Cloud Shell. Let's maximize the window from here, and I should be able to run the commands here, right? So there is nothing in my home directory as of now. Let's go back to the help documentation, and the very first command is to check the version of Azure CLI. So let's run this command to see what version of Azure CLI I'm running, and it is required to run Azure CLI version minimum at 2 root 0 root 64. So in this case, I'm already running on 2 root 9.1. So I'm good with that. I don't need to upgrade or do any change in there. And for your case, if you are using it from Red Hat Linux or from PowerShell window, right? So you must check if you are running at least this minimum version of Azure CLI. Otherwise, it may end up with some problems. So in order to upgrade the Azure CLI, so you can just refer this link and install the latest version of Azure CLI. Okay, so as we know in Azure, we when we launch any resource, it has to be a part of resource group. The very first command which we are gonna run is to create the resource group. So the command to create the resource group is az group create. Az group create the name of the resource group and the location where I want to run or create this resource group. Right. So hit enter. The ESUS is the region where I provision this resource group to, and I think the resource group should be ready now. You just go ahead to the second tab and search for the resource group. Click here and hit refresh. Then here we go. We have a resource group called my resource group, right? So resource group is already there. That's fine. And now you go back to your slide and see what is the next command to run. So next is basically to launch the cluster, and there is a note over here. So in case while launching the cluster, if suppose you want to enable monitoring for your cluster, and monitoring for your agent node, so then this is the option which you will choose in within the command, right? So this option can be enabled only when you have these two features registered with Azure, right? The features. So how do we check if these features are registered or not? So in my case, it is already registered. Let's see if it is registered or not. So it says it's registered. The second command to register this operational insight is basically this. Let's see if it is registered also. Yeah, that is also registered in my case. In your case, if it is not registered, then these are the two commands which you will run, and register operational management and operational insight to use enable add-on monitoring in your case. And if you don't want to enable these two features, and you are running this AKS cluster for the demo purpose, then you can just get rid of this option, and that will not enable any monitoring for your AKS cluster but still it will launch your AKS cluster, right? So let's copy this part, copy this command, and paste it in here. So in my case, the feature operation management and container inside, the operation inside is already registered, so I can use this argument therein within the command. Okay, so let's read this command. Uh, so here we are going to create AKS cluster. AKS create the resource group in which this AKS cluster to be created is my resource group. That is the same resource group which I just created 2 minutes back, and the resource, the name of the cluster would be my AKS cluster. Number of node counts or number of worker node will be 1, which will be as part of this cluster. And the final option which I'm using here is generate SSH keys. So what it will do, it will generate the SSH keys and put it in my home directory so that I can log in into the worker node with my SSH keys, right? So let's hit enter, and it will take a couple of minutes to launch this cluster. So I'll just pause my video here and we'll come back once the cluster is ready. Okay, so if you see in here, the AKS cluster is now ready to use, and this is the output. And it took around 7 to 8 minutes for me to launch this AKS cluster, and this is a big output which I was able to see in here. Let's switch to the next tab and see how many resources and how many resource groups are created as part of this cluster. So the recovery service role, it was already there, so let's ignore that one. And my resource group, this is the resource group where actual cluster, the AKS cluster is provision 2. And there is one more resource group that is called MC underscore my resource group underscore my AKS cluster underscore East US. And in this resource group, it has provisioned few resources like VMSS, load balancer, network security group, public IP address, and the virtual network. Right. So there is one more resource group that is called MC underscore my resource group underscore my AKS cluster underscore East US. That is just for route table. And there are two more resource group. One is for log analytics workspace, and another is for container insight for monitoring purpose. Okay, so so I was able to launch the cluster using that command. And next, let's see what we have to do. So in case you are not running these commands and not launching this AKS cluster from Cloud Shell, then you have to have kubectl installed. The command to install kubectl is basically this. And in my case, I'm already on Cloud Shell, so kubectl command is already there, so you don't need to install kubectl, so we can just safely skip this step. Next command is basically to download the credentials. So if you go into this directory, and so I do not have this directory yet created, so what I'll do, I will just uh, uh, copy and paste this command in here. It will do what? It will create a directory called .cube in this present working directory and create a file called config, and that config file will have the credential, the token and everything to connect to the AKS cluster. Let's hit enter, and here if you see in output, then it has created a .cube directory. So we have a config file here. So this is my token and everything. So now you should be able to connect to the cluster. Let's see, kubectl get nodes is the command to see how many nodes are part of this cluster. So as of now it is 1, because in my within my command I mentioned number of nodes. The node count is 1, right? So now the next part of it is we will run a sample voting application on top of it, and that will be provided by Azure in GitHub. So it is simple voting app which will be backed up by Redis database. So let's go ahead and get the code from the GitHub, clone this GitHub repo in here. So it is downloaded and cloned. So now if you navigate into this directory called Azure Voting App Redis, then you will be able to see this file which I'm going to apply to the Kubernetes, right? So let's first open it and understand what we are going to do. So I'm sorry. Okay. So this is my file, YAML file, which I'm gonna apply, and we have a deployment there with replica one. We and the name of the deployment we put it as Azure voting app, vote app, and we have some labels and mass labels and selector there, and then we have the image called Redis. So this is gonna do it is gonna launch a pod for the Redis, and it is supposed to 16379 port, right? And we are going to expose this on service of type and cluster IP on the port 6379, so that it is internally accessible but not outside. The second deployment we have is for front end, that is Azure board front. So we have some strategy defined over here, the selector, the label part of it, and the number of replicas which we are using here is one. And the image for this one is Microsoft Azure Word front column v1 as the version, and this is to be run on 80 port 80. And we have some resource constraint also defined, so resource CPU minimum maximum limits over here with some environment variable, right? So finally we are exposing this Redis also on load balancer type, so that we can access it from our browser, and that is again should be accessible on already. Let's come out of it and just go ahead and apply this file. So the command to apply on the file in Kubernetes is kubectl apply hyphen f, the name of the file which we are gonna apply, right? So let's hit enter. So here it has created the pod, the service, the backend pod and the service, and the front and pod and the service, right? So now if you run kubectl get pod, then you should be able to see two pods. That's it. So these two pods are in container creating state as of now. And let's see, we should see two services also there. And one is for Redis, that is on cluster IP, and another one is the front end service, that is our front end that is along with external IP, which we should be able to access it from, right? So let's wait until my pods are in running state. So one of the pod is already in running now. Let's wait for a couple of seconds. Yeah, so now I think both the pods are in running state. So let's grab this IP address from here and open a new tab and paste it in here. You should be able to access your application now. So let's see if pods are already in running state or not. Pod is running, and my IP address is 110, and yeah, my application is accessible now. And now you can just do the voting, cats dog, right? Do the voting, and finally you can reset it. So this is a sample application, which we are accessing in here, right? So we are able to launch the cluster, we are able to access and deploy the application on top of it. Now let me walk you through as how many services are launched in the backend when you launch a AKS cluster, right? So as I told you already, so after provisioning, it will launch few services, these resources, right? So after deploying this service, if you see, it may have launched a load balancer with public IP address, which we are accessing from our browser. So that's it. That is the only extra resource which was added when I provision and when I deployed this app. Right, so that's it, and we are able to test the connectivity and verify everything. And the final command which you will run to delete the cluster is this one. So this is again the simple command syntax here. So az group delete. So here with this command we are just going to delete this resource group, so that it will remove all the resources which are there inside this resource group, right? With no wait option, so that we get to the prompt again immediately, right? So without wait. And if you go ahead and start refreshing in this tab, then you will be able to see all these resources that are being removed after a couple of minutes. So That's it for now. And one more thing which I would like to highlight here is you may need to delete two resource groups manually from here, because those two resource groups will not be deleted as part of this command. So those two are uh, the monitoring resource group, like the default resource group EUS, as well as the container inside resource group. So these are the two resource group which you may need to delete manually. Other than that, everything will be deleted as part of this command. Right. So that's it for now. And in my next session, I'll show some more demos and more videos on Helm chart and integration of AKS with ACR, that is your container registry. So that's it for today. Thank you. Thank you very much.